So we just did these questions, right? We did question 2 together. So why don't you guys try question 3 and 4? So here's question 3, right at the bottom of the page. And then question 4 got kind of cut off. So I'm just going to put it up here. So this is the end of question 4. So it starts up here. So just do a quick pause and then try it out. So 3, 2, 1, pause. Okay, so hopefully you guys tried those 2 questions out and they weren't too bad itself, right? So now let's do this together. Okay, so question 3 says, given the mean test scores, the sample to be 79 points with a standard deviation of 9.8 points. So notice the same template, right? Same framework. So I'm not trying to trick you. It's going to be the exact same process, every day, every question. A, determine the percentage of students who got scores within 3 standard deviations of the mean. All right, well, trick question. If you're 3 standard deviations away, according to the empirical rule, what percentage is guaranteed? 99.7, right? So that was just knowing the rule, right, when it came to it. B, determine the percentage of students who got scores between 59.4 and 98.6. All right, so for this one, we got a little bit more work to deal with, right? So for here, I'm just going to do our little chart. So we have 79 here as our mean, and we're going to go, right, because I'm not sure if it's 1, 2, or 3 away when it comes to it. And we're just doing a little practice, right? So if I go 1 away, so 79 plus, what was it, 9.8, gives us 88.9. Sorry, 8.8, which is not that one, right? So that's not going to be it, but let's just try again. So 79 minus 9.8. This is 69.2. So not what I wanted, right? So it's not 1 standard deviation away. So let's try one more. So let's just add it to it. So if I did 2 standard deviations away, so little marker's a little off, so I'll do that marker. This is 98.6. All right, that's got what we want. Just make sure the other one is also correct. So 79 minus 2 times 9.8, because that's 2 standard deviations away. We get 59.4. Hey, that's exactly what the question was asking, right? Between there and there. So since we're 2 standard deviations away, we're guaranteed how much? 95%. And there we go. Right? So question 4, very similar, right? Just only thing that changes is the means out, right? So we actually did kind of this a little earlier. So question 4 is with a mean of 100 and standard deviation of 15. So just write this down. So mean of 100 and a standard deviation of 15. What percentage of people will fall within 85 and 115? So again, right, we actually did this earlier, so I'll just pop this up there, right? So 85 and 115, that's 1 away, so that is 68%. Okay. And then part B, what range of values will fall within 95% of the mean? So this is the opposite. So they give you the percent, and they ask you what 2 numbers is it fall within. So that's just going backwards, right? So what we know, we did this earlier. So this is 1 away, this is 2 away. So we're looking for here. So 2 away is 95%, right? That's what the question was asking. So the 2 numbers that's between is 70 and 130. So we write between 70 and 130. Or you can say 70 to 130. But we write both of the numbers themselves. So those are ranges. So you don't subtract them, right? Because we want the 2 numbers. So those are the 2 boundary points that guarantee 95 within those 2 numbers themselves. Okay. So that's the empirical rule. So the thing is, when it comes to empirical, it's kind of limited. The reason why I say it's limited is because the empirical only works if it's a normal distribution, unfortunately. But life isn't perfect, right? Life isn't always normal, so we have to tweak it. So that comes into the next play. So if it's not normal, like skewed right or skewed left, right? Those are not normal curves. We have to use a different way of doing it. Now, a smart guy came along, and he invented his own theorem. It's called Chebyshev's theorem. okay, when it comes to it. So the only difference between Chebyshev's and him is one thing. Chebyshev has two criteria. The empirical rule has three. Okay, that's the first one. The second difference is, according to the empirical, right, if you're 2 standard deviations away, you're guaranteed what? Hopefully say 95, right? He says at least 75%. So that's the second major difference. The percentages are off. According to the empirical rule, if you're 3 standard deviations away, you're guaranteed what? So hopefully you said 99.7%. According to him, you're at least 89%. So those are the two differences. So one, there's only 2 criteria for him. So you skip, notice you skip 1 at all. It goes straight to 2 and 3. So you skip 1 completely. So it's 2 and 3. So it's only 2 criteria. And the second thing is the percentages also change. But the good thing is the work is identically the same. Okay. Now in the questions, they're going to specify use this theorem or the empirical rule. So they're not going to just randomly guess when it comes to it. They'll tell you which one to use. That way you can figure out which percentages you're going to use from there. Okay. So I give you a picture of roughly what the Chebyshev theorem will be applied. So notice we skip 1, right? Notice we don't even care about 1. That's why we skip them. We go straight to 2 and then 3. Okay, when it comes to it. So why don't we try an example like this? So question 5 at the bottom says the mean score of an insurance company lecture examination is 75 with a standard deviation of 5. So let me just write this down here. So mu was, I believe, 100. Oh, sorry, 75. And sigma is 5 in this case. Question is, what percentage of data set lies between 60 and 90? Well, this is the same thing, right? So same process. Instead of now 7 numbers, however, we only need 5 numbers, right? Because we're skipping 1. So our mean is still in the middle. And now we're going to go to 2 and then 3, because again, we're skipping 1. So it's going to be 75 plus 2 times 5, which is 10, so that's 85. And then 75 minus 10, which is 65. So that's not what I want, right? So it's not 2 away. But so it's going to be, 3, but, just check just in case. So the 75 plus 3 times 5, which is 15, so that's going to be 90. And 75 minus 15 gives you 60. And that's what you want, right? That's the question you want, between 60 and 90. So according to Chebyshev inequality, if you're 3 away, you're at least 89%. So therefore we say at least 89%. So notice the work is exactly the same. The only thing that changes is the percentages from a rule to rule. Okay. All right, part B, what is the percentage and range? So 2 things, 2 different questions of the data set that is going 2 standard deviations from the mean. All right, so this is the easy one. So if I'm 2 standard deviations away from the mean, what's that percentage according to Chebyshev? You're at least 75%. So we got half the problem. So at least 75%, because they were told is 2 standard deviations away. Now that's the first part. The second part is they also want the range, meaning what are the 2 cutoff numbers? So from there we could just use our little chart here, because we know that's 2 and 3, right? So it's between the 2 numbers, so it's between 65, so the range is between 65 and 85. Okay. So at least 75% of all the data values are between 65 and the 85. Okay. All right, last question in this section, question 6. So again, this is how it's going to label, right? Using Chebyshev's theorem, where IQ scores have a mean of 100 and standard deviation 15, A and B itself, right, when it comes to it. So why don't you guys try these real quick, and we'll do them together. Okay, so I hope you guys tried them. So determine the percentage of scores that lie between 70 and 130. So hopefully you guys got at least 75%, because it's 2 standard deviations away automatically, right? So mean of 100. So if I add 30, that's 130. If I subtract 30, you're at 70, right? So you're guaranteed 2 away. So last one, determine the range of scores within 3 standard deviations of the mean. So, and then what percentage is that within it? So the first one is easy, right? So your 3 standard deviations are at least 89%, and now find